Now we bring the course together. A Besu network is not production ready simply because it runs. In this final module, we'll focus on launch readiness, operations, governance, security, lifecycle planning, and the trends shaping sustainable enterprise Ethereum platforms. So far, we've built the foundation: Besu concepts, architecture, development, governance, security, and deployment. Now the focus shifts from building the network to judging whether it is ready to operate safely, reliably, and sustainably in production. Getting a Besu network to run in a lab proves the components can work. It does not prove the network can handle real business conditions. Production readiness asks a broader question. Are the people, processes, technology, and risks controlled? Security, monitoring, recovery, governance, compliance, maintenance, and scale all need to be validated with evidence, not assumptions. Checklists, rehearsals, test results, logs, audits, and formal sign-offs turn "it works" into "it operates." A production checklist turns readiness from opinion into evidence. Before a Besu network goes live, validate the architecture: topology, node roles, consensus, segmentation, and exposed endpoints. Then prove the controls: permissioning, TLS, secrets, validator keys, and access. Operations must show monitoring, alerts, logs, backups, and rehearsed recovery. Governance confirms who can change what, how participants join, how data is handled, and whether the deployment meets policy and compliance expectations. Any unclear answer should become a launch blocker, not a post-launch surprise. At the architecture level, production Besu networks should separate responsibilities instead of treating every node the same. Public traffic should terminate at controlled entry points, pass through firewalls and load balancers, and reach RPC or API nodes, not validators directly. Validators, boot nodes, monitoring, storage, and application services each need their own access rules and failure assumptions. Also confirm disk performance, growth, backups, and automation, so environments can be rebuilt consistently when demand increases or incidents occur. Security readiness is a production gate, not a final polish step. Start by reducing what can be reached. Expose only required RPC methods, and keep admin APIs away from untrusted networks. Then protect signing authority. Validator and account keys should live in vaults, HSMs, cloud KMS, or controlled signing services. Finally, align node and account permissioning with governance. TLS, firewalls, authentication, secret rotation, and privileged access should work together as one connected control system. In production, monitoring is more than checking whether servers are alive. It is how teams see risk forming early. Besu metrics show peer count, block height, consensus status, transaction pool pressure, and RPC latency. Infrastructure metrics show capacity limits in CPU, memory, disk, and network. Logs and traces explain why something happened. Alerts, runbooks, escalation paths, and SLOs turn that visibility into fast action and reduce downtime. Disaster readiness begins with RTO and RPO, how fast you must recover and how much data loss is tolerable. From there, protect everything needed to rebuild: configurations, Genesis files, permissions, keys, application state, and runbooks. During an incident, teams need to detect the issue, assess impact, isolate affected services, restore or rebuild nodes, validate chain sync, and resume operations. Most importantly, rehearse failover, validator replacement, and communication roles before a real outage. Enterprise Besu networks need more than working nodes. They need an operating model that makes decisions traceable. Governance defines who can join, who can validate, how votes happen, and how exceptions are handled. Compliance turns those decisions into evidence through audit logs, access reviews, approvals, and configuration baselines. Production control also protects change, from Besu upgrades to contract deployments and emergency fixes. The goal is simple: every operational action should be authorized, documented, reviewable, and aligned with legal data obligations. Performance is best treated as a set of levers, not one magic setting. Block time affects latency, but shorter intervals increase pressure on validators and consensus. Gas limits affect how much work fits in each block, but heavier contracts consume that capacity quickly. Storage, indexing, RPC traffic, and integrations can become bottlenecks as well. The right approach is to define realistic workloads, measure throughput and response times, and tune against clear service targets. Capacity planning has two distinct goals: keeping consensus healthy and serving applications reliably. Validators should not carry heavy RPC traffic because query spikes can compete with block processing. Put application access behind gateways, load balancers, rate limits, and caching. Then scale RPC nodes based on CPU, memory, storage I/O, network traffic, and retention needs. For complex reads, use an indexing layer or database so applications query prepared data instead of stressing Besu directly. Not every enterprise workload belongs on-chain. A stronger pattern is to use the chain as a trust anchor. Store hashes, proofs, and state commitments there, while large files, sensitive data, analytics, and identity checks run off-chain. Events connect smart contracts to ERP, CRM, and data platforms through listeners, queues, and middleware. Batching and asynchronous processing reduce load. Bridges can extend reach, but they require careful controls when assets or regulated data cross networks. Lifecycle work in production should be handled as controlled change, not a quick patch. Track Besu, plugin, client, operating system, container, and infrastructure versions together. Review release notes, then test the exact procedure in a lower environment that resembles production. After approval, take backups and roll forward gradually, upgrading a limited set of nodes first. Validate compatibility, monitor network health, and keep rollback, communications, and closure evidence ready. Change management in a Besu network goes beyond upgrading nodes. A contract change can alter business rules. A validator change can alter who has consensus authority. Permissioning and configuration changes can affect access, stability, and compliance. Each change type needs its own approval path, test plan, and rollback strategy. Just as important, preserve the evidence. Contract addresses, ABI versions, validator identities, deployment records, and governance approvals. In production, traceability is part of the control. Production-ready Besu is not one capability. It is a disciplined operating model. It combines resilient architecture, security, monitoring, compliance, scaling plans, and lifecycle governance. From here, apply the full course to real implementation reviews, and keep tracking the trends shaping enterprise Ethereum: interoperability, privacy, tokenization, regulated assets, and AI-enabled operations.